Hi my dear students, last class we studied about AC circuit with resistor. In this class we are going to discuss about AC circuit with an inductor. We all know about the inductor. Okay, when an inductor is connected to an AC circuit, an alternating source of EMF, what will happen? Okay, that is one of the most important topic. Listen carefully. Let us consider an alternating source of voltage, an alternating source of EMF which is connected to an inductor of inductance L. That is, the coefficient of self-inductance is L. Here we apply what? EMF, the alternating source of EMF, which is written as E is equal to E naught sine omega t. We know E naught is the maximum value of induced EMF, E is the instantaneous value of EMF, T is the time period, and omega is the angular frequency. Okay, we are all know about the terms. E is equal to E naught sine omega t. Okay. But our ultimate aim is, first we want to find the induced current, and then we compare the induced current and the induced EMF in the inductance circuit. How we measure the induced current? Okay, let us write. When this EMF is applied to the inductor circuit, this inductor can able to produce an opposing induced EMF which opposes the applied EMF. Okay, the expression for that is equal to E is equal to minus L into di by dt. This is an induced EMF. This is induced EMF. This is applied EMF. Applied EMF and the induced EMF are opposite to each other according to Lenz's law, because the induced EMF opposes the applied EMF. So it goes in this direction and the applied EMF goes in this direction. So both are opposite. So then we can write, for we make the difference, E becomes E dash. E dash is the induced EMF, E is the applied EMF. So E is equal to minus E dash, because both are in opposite direction. Then E is equal to minus of, instead of E dash we write minus L into di by dt. So the next step, E is equal to minus of minus plus, so L into di by dt. But what is our aim? Our aim is to find the instantaneous value of current and then we compare. Okay, here the current is di. Then the di is equal to E into dt by L. Okay, E into dt by L. This is dA. Okay, but we want I. How to calculate I in terms of how to calculate I from dA? Before that, we substitute the value of E. E is equal to what? E is the induced EMF, which will be equal to E naught sine omega t into dt by L. Integrate on both sides. Integrate on both sides. Then we get the value of I. So I is equal to integral of dA, which is equal to integral of E naught. This is what E naught sine omega t dt by L. Okay, integral of di is equal to E naught by L is a constant, so it is taken out. The remaining term is integral of sine omega t into dt. Okay, then we integrate di, it becomes I. Integrate di, it becomes I. So I is equal to E naught by L sine omega t dt. Integral of sine omega t dt is nothing but it is minus cos omega t by omega. So I is equal to E naught by L omega into, minus is here, so minus E naught by L omega into cos omega t. This I is a instantaneous value of current, so it may be small. So we can write small I. Okay, this becomes small, everything into dA by dt. Okay. Okay, everywhere I changed capital I into small I. So this is I is equal to E naught by minus E naught by L omega cos omega t. Okay, into cos omega t, right? Then next, what we will do? Okay, I is equal to minus E naught by L. Okay, then if cos omega t equal to 1, if cos omega t is equal to 1, then the current passing through the circuit will be maximum. If cos omega t is equal to 1, then the current passing through the circuit to be maximum. Okay, if cos omega t equal to 1, then the expression becomes I is equal to, I naught is equal to, because the maximum current is written by I naught. So I naught is equal to E naught by L omega. Okay, just listen. When cos omega t equal to 1, if cos omega t equal to 1, that means cos omega t attains its maximum 1, then the expression becomes I equal to E naught by L omega. This is the maximum value of induced current. Substitute I naught equal to E naught by L omega in this expression. Then this is expression number 1. Substitute this in this expression, then I is equal to minus of, instead of E naught by L omega, we write I naught cos omega t. Yes, correct. But the induced current, the instantaneous value of current is in the terms of cos omega t. The instantaneous value of EMF is in sin omega t. So we change this into sin omega t term. How? Cos theta. Cos 90 minus theta is equal to cos theta. Sin 90 minus theta is equal to cos theta. So we can write here sin 90. 90 means pi by 2 minus theta. Theta equal to nothing but omega t. So my sin 90 minus theta equal to cos theta. Here I write here sin 90. 90 means pi by 2 minus theta equal to sin 90 minus theta equal to cos theta. So this formula I can use here. Sin 90 minus theta equal to cos theta. Here cos omega t. So sin 90 minus omega t. Okay. Then it looks like in a form of sin of minus theta equal to minus sin theta. Right here, sin of minus theta equal to minus sin theta. Okay, sin of minus theta equal to minus sin theta. Okay, how I use this expression here? Here I is equal to minus I naught. Here minus, here also minus. Sin theta, here also sin pi by 2 minus omega t. So the next step, I is equal to sin of minus theta. This minus goes inwards. Then I naught, where is I naught? I naught sin of minus pi by 2 minus of minus plus omega t. Then the expression becomes omega t minus pi by 2. This is the equation number 2. Now look at the equation number 1 and 2. Equation number 1, E is equal to E naught sin omega t is the instantaneous value of induced EMF. Applied EMF. Sorry. This is an instantaneous value of EMF. Here, this is the instantaneous value of current. I equal to I naught sin omega t minus pi by 2. So this is omega t sin omega t. This is sin omega t minus pi by 2. These are the two expressions, most important expressions. Get it from the AC circuit with the inductor. Okay. Then what we infer, what we concluded from these two expressions. This is sin of omega t. This is sin of omega t minus pi by 2. We learned earlier, we learned in the last class also, last video, last lecture also, there is a phase difference between them. Here there is a phase difference between E and I. What is the phase difference here? The phase difference between E and I is nothing but pi by 2, because I is equal to I naught sine omega t minus pi by 2. That means current lags behind the EMF by the phase angle pi by 2. Otherwise, EMF leads the current by the phase angle pi by 2 in an AC circuit with inductor. Here the current is lagging, EMF is leading. That means when an alternating EMF, when an alternating voltage source is applied in an inductor, it produces current after a certain time. When the EMF is applied after the phase difference pi by 2, there is a current in the circuit. Okay, there is a phase difference. So the phase difference between EMF and current is, here is pi by 2. Here EMF leads the current by the phase angle pi by 2. Okay. Don't forget, this is most important thing. So now we discussed what are the facts we discussed here. First one, diagram. I think all of you understood the diagram. Second one, E is equal to E naught sin omega t is the expression for instantaneous EMF. Third one, I equal to I naught sin omega t minus pi by 2 is the expression for instantaneous current. Fourth one, there is a phase difference between EMF and current. And also EMF leads the current. EMF leads current by the phase angle, by the phase difference or phase angle pi by 2. These are the four important things we learned here. Now 1, 2, 3, 4. But we can represent the phase difference between current and EMF by two ways, not only by the expression. Another two ways are there. First one is expression, second one is wave diagram, third one is phasor diagram. We are now going to discuss about wave diagram and phasor diagram in detail. Please wait here. First, wave diagram. The fifth thing we are going to discuss about is wave diagram. In the wave diagram, there is an x-axis here. What? The time t is taken. Okay. Y-axis E comma I. Where E is the EMF and I is the current. First, I draw the EMF. Okay, this is EMF. Then where is the current? This is 0, this is the phase difference pi by 2, and this is phase 0, this is phase pi by 2, this is what? Pi, and this is 3 by 2 pi, and this is 2 pi. Okay, this is for what? EMF. What is the representation for current? The current lags behind the EMF. So the current starts from pi by 2. So when the EMF is in pi by 2, the current starts. Okay. Yeah. This is current diagram. Here, look at the phase difference. The phase difference between any 2 points we are taking is pi by 2, 0 to pi by 2, pi by 2 to pi. The phase difference is pi by 2. The red line shows this is current, and the black line shows, black wave shows this is EMF. So EMF is first going, the current is following the EMF in the same way, but there is a phase difference. When the EMF is in its maximum, the current will be its minimum. So both EMF and current are in phase difference pi by 2. If the EMF is maximum, the current is minimum. When the current is maximum, the EMF is minimum. So both are pi by 2 degree out of phase. There is a phase difference between them is pi by 2. Here who is leading? EMF is leading. These are the most important things. So here this peak value, this represents what? This represents E0. E0 is the peak value of the induced EMF, and I0. This is what? I0. I0 is the peak value of the induced current. This is I0. Look at the diagram. E0, the magnitude of E0 is greater than I0. Why? Because I is equal to E by R. We know very well I is equal to EMF divided by resistance. So I is less than E. E is greater than I. Whatever it may be, that is the true concept. Okay. This is about wave diagram. The another way of representation is what? That is phasor diagram. Phasor diagram. Okay. I draw here. The next thing is phasor diagram. Let us consider this is what? This is E0. This is E vector. The length of the vector is E0. Let us take at a time t, it makes an angular velocity, angular frequency omega. So omega t, theta equal to omega t. So it makes an angle theta or omega t with the x-axis. Here this is E0. Okay. What is the value of induced EMF? Instantaneous EMF. What is the value of instantaneous EMF here? The value of instantaneous EMF is this. This is what? E is equal to E0 sine omega t. The projection of E0 vector gives instantaneous value of EMF, which is nothing but E equal to E0 sine omega t. What are the things we observed from the phasor diagram? The length of the vector gives E0. Here there is a vector EMF vector which makes an angle omega t from the initial position. It is rotating in the anti-clockwise direction. The projection of E0 vector gives the instantaneous value of EMF, which is nothing but E is equal to E0 sin omega t. Okay, this is about EMF. What about current? The current I equal to I0 sin omega t minus pi by 2. That means it lags behind the EMF by the phase angle pi by 2. So where is the current here? The current is yes. Okay. This is current vector. Okay, this is current. Okay, I0 is the maximum value of the current. The length of the vector gives I0. Look at the diagram. There is a phase difference between E0 and I0. How much? It is exactly perpendicular. That means pi by 2. So there is a phase difference between E0 and I0. How much? Pi by 2. So pi by 2 phase difference. Who is leading? EMF is leading. Current is following the EMF at the phase angle pi by 2. What is the instantaneous value of current? The instantaneous value of current is this. This is nothing but I is equal to I0 sine omega t. This projection gives EMF. This projection gives current. Both are rotating in anti-clockwise direction. The angle between them is pi by 2. E is equal to E0 sine omega t here. So the EMF makes an angle omega t with the initial position. The current makes an angle omega t minus pi by 2. Omega t minus pi by 2. Because EMF is in the angle omega t. Okay. Both are rotating in anti-clockwise. Okay. When the when the EMF, look at the diagram, when the EMF rotates here, it goes its maximum, it reaches its maximum, because when it rotates and it reaches the point, it goes to its maximum. Sin omega t becomes 1, then E equal to E naught, it goes to its maximum. That means the EMF is increasing when it is rotating this direction. At that time the current is rotating here. What will be the value of the current? When the current is rotating anti-clockwise, its instantaneous value will decrease, because when it rotates here, for example, when it reaches here, its value, the instantaneous value becomes lesser. So EMF is decreasing, EMF is increasing, current is decreasing at the same time. Why it happens? Because of the phase difference between them. Exactly, the phase difference between them is pi by 2. So when the EMF is increasing, the current is decreasing. These are the informations we studied from this phasor diagram. So we discussed 4 things. This is the 5th thing, wave diagram. This is the 6th thing, that is phasor diagram. From the 2 diagrams, we very well know about the phase difference between the EMF and the current. Another one factor is remaining. That is what? That is opposition. Opposition given by the inductor. That is one of the most important thing we are going to discuss now. Okay, I will start from here. What is the opposition given by the inductor? This is a inductor of inductance L, which is shown in the figure, which is connected in the alternating source of EMF. Yes. What opposition the inductor will give? The inductor will give opposition, but it is not a resistance, because the inductor is made up of pure copper. It contains a negligible resistance, so we can neglect. So considerably there is a zero resistance in the inductor. So there is no resistance in the inductor, but there is opposition in the inductor. Listen my words carefully. There is no resistance in the inductor, but there is a opposition in the inductor. Who provides opposition? When an alternating source of current flows through the inductor, it produces a magnetic field because of the alternating, changing, time varying current. It produces a magnetic field, changing magnetic field, which produces an opposing induced EMF. We know very well about that. There is an opposing induced EMF. I told you from the starting. So that opposing induced EMF will oppose the growth of current here. That is the property that is called self-inductance. Okay. Let us be discussed. Here I naught is equal to E naught by L omega. Here I naught is equal to E naught by L omega. Before we are going to discuss here, we can find the opposition by numerically. That means expression. The opposition expression for opposition is any opposition we can measure. I is equal to V by R. Yes, this is Ohm's law. V is equal to I R, I is equal to V by R. V by R, voltage by resistance gives current. Here R is the opposition generally, but in this case here V is nothing but that is EMF here. Okay. In the case of resistor, resistance is the opposition. In the case of inductor, L omega is the opposition. L omega. R is equal to L omega here. Resistance equal to L omega. What is L omega? Omega is nothing but it is angular frequency. Okay. L is the inductance, coefficient of self-inductor or self-inductance. Okay, self-inductance. L. Okay, omega is the angular frequency. Angular frequency means number of cycles in 1 second. It may be a 2000 cycles in 1 second, or 200 cycles in 1 second, or 2 cycles in 1 second. Whatever it may be. So the number of cycles in 1 second is said to be angular frequency. Look at this expression. The product of angular frequency and the inductance gives gives some opposition. Okay, if this value is very large, L omega is very large, then I naught will be very small. I naught, not I naught, I will be very small, because these two are inversely proportional. From that expression we infer that I is inversely proportional to omega L. Yes. If the opposition is very large, the current flow is very small. If the opposition is very small, the current flow will be very large. Okay. How we can increase and decrease the opposition? Is there any way? How? Yes, there is a way. Here omega into L, the product of angular frequency and the inductance gives the opposition. We can't change the inductance because the inductance for a particular inductor circuit is constant. When it is made, then it will becomes constant. Which is constant? Inductance is constant. L is constant, but omega is changing. We can able to change omega. Omega is the angular frequency. If we are giving high frequency here, the opposition is also higher. So the opposition is determined by especially omega, that is angular frequency, because L is constant here. So when we are increasing omega, angular frequency, there is a high opposition. If the frequency is lesser, then there is a small opposition. So the opposition is fixed by the factor especially omega. Omega is the action and opposition is the reaction. So here some reactance is done. So this is what called as reactance. So there is some reactance of the angular frequency. Angular frequency makes some reactance. Okay, this reactance is held in the inductor circuit. So this is called as inductive reactance. Is there any special letter to represent inductive reactance? Say yes. XL. XL is the inductive reactance. L for inductor, X for reactance. So XL is the inductive reactance. What is inductive reactance? Inductive reactance is nothing but resistance offered by the inductor or opposition offered by the inductor. Okay, opposition offered by the inductor or resistance offered by the inductor. The correct word is not resistance. The opposition offered by the inductor circuit is known as XL, that is called inductive reactance. What is the unit of inductive reactance? The unit of resistance is ohm. Resistance means what? It gives some opposition to the current, applied current. What is inductive reactance? It gives some opposition to the applying current. Both are doing the same work, so both the units are also same. So the unit of inductive reactance is nothing but it is also ohm. Ohm is the unit of inductive reactance. So we know very well about, now we know very well, we learnt about inductive reactance, representation letter, unit, what is inductive reactance and how they formed, all things we know very well about it. Okay. So the angular frequency determines the opposition. If the angular frequency is large, opposition is large, the current passing through it is small. If the angular frequency is less, the frequency is less, the opposition is less, and the current passing through the circuit will be more. Okay? Okay, there are two things we are going to discuss now. The last two things, what are they? First one is I is equal to E by L omega. This is for any condition. This is for maximum condition. This is for any condition. So I write, instead of I naught, I write I is equal to E by L omega. In an AC circuit, the frequency is high. Let us consider high frequency AC is applied here. So when we apply a high frequency AC, then the expression becomes I equal to E by L omega, we are applying high frequency. Omega is nothing but omega equal to 2 pi nu. Okay, this is what angular frequency. Okay. When we are increasing the frequency, the current will down because the opposition is large. In the case of AC, in the case of high frequency alternating voltage is applied, here I termed high frequency. So the frequency is higher, so the current passing through the circuit will be less. If it is very high, consider, let us imagine, assume if the frequency of the AC voltage will be so much higher, then the opposition will be higher, the current passing through the circuit will be blocked. So an ideal inductor, not only ideal inductor, an ideal inductor with high frequency alternating source is applied in an inductor, it blocks AC, that is the point. Blocks AC. AC means alternating current. When a high frequency alternating voltage is applied to an ideal inductor, it definitely blocks AC. Don't forget, it is one of the important points. Second one is, in the case of DC, this is, as the name indicates, DC, direct current, steady current, so there is no frequency. Because here the current is going straight, there is no fluctuation, there is no changing in the direction after a certain regular intervals of time. So there is no frequency here. So then this expression I is equal to E by L omega. Here omega becomes very less. For example, very less when it is 0. In a DC, the frequency is 0. Then the current value goes to infinite. The current becomes maximum. The current is infinite. So it allows DC very much because there is no opposition. Why there is no opposition? Because the frequency is 0. If the frequency is 0, there is no opposition. If there is no opposition, the current will easily pass through it. The current will pass infinitely. So the maximum DC current will pass through the inductor circuit, and inductor circuit blocks AC. That is one of the most important points. These are the things, most important things now we discussed in this AC circuit with inductor. So I explained diagram, expressions, how they formed, how they derived, I explained very well. Phasor diagram, wave diagram, opposition. All these are important concepts. So please listen while you are watching the video carefully. Carefully watch the video and make use of it. This is one of the most important topic. We will see the next question in the next video. Till that, bye friends. Thanks.